This is 2009, right, ordinary level envelopment question. Now the 3D graphic below shows a glass jar and a label which is to be wrapped around it. The drawing on the right shows the plan and elevation of the label and the cylindrical portion of the glass jar. Right, so the cylinder here, right, a cylinder and elevation, a vertical right cylinder will appear as a rectangle, and you'll see the top with the circle and plan. Complete the elevation showing the label in the wrap position. So at the moment the label is in the open position as shown in the 3D graphic. We have to wrap that around. Now this, like in the developments, when you had a curved surface in development, did you draw, if you remember the developments, did you draw an exact shape of the development, or was it an approximation? Approximation, because when you had a curve you divided it up 30-60 and you took the straight line distance there. We'll be doing the same here, right? So what we'll do is you do what you normally do with your circle, 30 degrees through the center, 60 degrees, 30 degrees this way, 60 degrees this way, right? Now I'm going to mark out my distances here, along here, right, with my compass. But again, when I take this distance here, I'm actually taking the distance of the straight line from there to there, and the straight line from there to there, and the straight line from there to there. So it'll actually be slightly off. But as far as this level goes, that's perfect method to do it, right? So this will be your first distance there. That'll be your second, right? So 1, 2, 3, 4, right? And there's a small bit left at the edge. Now what you do then is, to get the first height here, you'll take it up, right? That's the point there. You take the second point up, take this point up, and you project it in there to get that point. Now the next point then, take this point up, and that's the outside edge there then. Now this is going to be a freehand curve, right? Now the reason we know that's the outside edge is, right, if that's 1, this is 1, that's 2, this is 2, 3 is on the edge, so this will be 3 here. So that's the height of it there when it's at the outside edge, right? Now we'll go to 4 there, right? 4 down here. Take that in. Now then we bring 4 straight up, which should be there. Now is that heavy there when it's gone behind the outside furthest right hand point of the cylinder? The fact that it's gone behind the right hand side edge now means that it's gone behind, so it's hidden. So these be dotted, right? Now then we're still not finished, right? We've one small little 5 out here, okay? Now that distance here is the same as, okay, we'll say 1 was there, 2 was here, 3 was there, 4 was there, and now 5 is there. So when I bring 5 in like this, right, what I'm missing is my 5 here. So I have to get my distance from 4 out to the edge here, right, which I can't do because the lead is too small on the compass. So what I'll do is I'll just take measurement. It's 2 mil, so I'll take that measurement here from 4, it's 2 mil, so that's 0.5 there. So to get 5 up here, I'll project it straight up till I get the line coming in from 5, and that's there. Alright, now then what happens at that outside edge then? It's vertical straight down, so this one here will be vertical straight down. Okay. Now, you'll notice again that the distance from the center out here and the distance from the center to there is even. So basically what we've done here, you could do axial symmetry in this red dotted center line. I can just take the heights across and take them up here. So we'll basically take the heights across again there. Right, and then to get where they are here, we'll call this maybe 6, 7, 8, 9, and then we'll add 2 mil to get the 10 back behind it here. Just add the 2 mil there, right? That will be 10. So you take them up, right? So 6 here, right, will be straight across from 1. That's where 6 is there. 7, right? 7 will be the same height as 2. So that's 7 there. 8 will be the same height as 3, right? We know that's out on the outside edge, so we'll have that there. So that's the front, what we see on the front. Then what we'll do is we'll get a 9 underneath. 9 is the same height as 4. So 9 goes up there and across from 4. And then finally 10 will be the same height as 5 here. Right? And that's dotted there then. And dotted straight down. So that's 2009 envelopment question. Same principle with them all, is to take your widths here, right? The first two are easier. Now this was 2009, it was the first year of this, and people obviously found the curve too difficult, so since then it's only ever come up as either a square or a hexagon, which is straight edges, which is a lot easier than the curve, because to do this one you'd have had to know to divide it up at 30, 60, 90. But that principle comes, developments and envelopments are the same topic, right? One of them is having an object and opening it out, developments, and then this one, envelopments, is having the object opening out and closing it together.